welcome back to my YouTube channel Trouble Free. In today's video I am going to explain you the concept of KCL with an example problem. In the previous video we just discussed about what is KCL and a simple example problem along with some rules which you have to follow when a complicated circuit is given, right? So now let us see how to exactly solve that complicated circuit. So before getting into the video, I would recommend you to watch my previous video where I explained about the rules. Let us quickly revise those rules. First one is identify all the branches. First step, you have to identify all the junctions. Next, you have to assume the initial voltage V0, which is equal to 0. Then you have to assume the unknown current directions and form KCL equations. Unknown current directions in the sense, if the direction of the current is not given in the question in the circuit diagram, you have to assume by yourself. And it is always better to assume all the unknown currents in one direction only, so that there will be no confusion. Okay, so I'll explain you again with this problem step by step. Don't worry. Okay, so first what you have to do, identify all the junctions. So here you have to identify all the junctions. What do you mean by junction? A place where 3 or more branches will connect, right? So what here, only 2 branches are connecting, so this is not a junction exactly. So here also only 2 branches are connecting. Guys, look at here 3 branches are connecting, 1 2 3. So let us identify this as junction A. And here also 3 branches are connecting, 1 2 3. So let us identify this as junction B. Okay, now we have to assume the initial voltage V0 is equal to 0 volts. So we have assumed initial voltage V0 which is equal to 0 volts. Okay, and assume all the unknown currents in the outgoing direction. As I told, it is always better to assume all the unknown currents in the same direction, whether it could be incoming direction or outgoing direction. Okay, so now we have I1, I2, I3 and I4, I5, I6, right? Now assume all the currents in outgoing direction. That means I1 is going out, I2 is also going out, I3 is also going out. Here I4 is going out, I5 is also going out, and I6 is also going out, let us assume. Okay, now we have to apply KCL at each junction now. Okay, what does KCL say? The sum of currents, all the currents at a junction is equal to 0. So we have to apply KCL at both junction A and junction B also. So now let us apply KCL first at junction A. Let me tell you the question properly. Find the current in 3 ohms resistor using KCL. Where is the 3 ohms resistor? The 3 ohms resistor is over here. Okay, so you have to find out the current in 3 ohms resistor, that is I2, you have to find out using KCL. So that means you have to find out the value of I2. Let us form equations, and then from those equations let us try to find out the value of I2. Okay, so let us do this. Right, so this is the circuit diagram. Okay, and I am going to form the KCL equation over here. Okay, so at junction A, sum of I should be equal to 0, right? What is I from Ohm's law? From what does Ohm's law say? V is equal to I into R, right? From that you can write I is equal to V by R, correct? Now let us apply the same concept here. How do you write? I1, I2, I3. Every current is going in outwards direction only, right? So you can simply write I1 plus I2 plus I3 is equal to 0. Since every current is going in the same direction, you can write I1 plus I2 plus I3 is equal to 0 directly. Now how do you express I1? So in I1, how many branches are there? 1 2 3, right? Sorry, not in I1, in junction A. Okay, you can assume it as VA, the potential difference over here as VA and the potential difference over here as VB, like that you can assume. For VA, I mean at junction A, I1, I2, I3, first let us write an equation for I1. So you go like this, right? You have to find out the, first what you have to find out, all the potential differences associated over here. First, what is there here? VA. Okay, current always flows from higher potential to lower potential. So you will take VA as positive only. Okay, because current is going from here, right? Here like this it is going. So you will take VA as positive only. Why? Because current will always travel from higher potential to lower potential. That means VA is at what? Higher potential only. Next, VA minus. What do we have here? Let us take this one later. Now, what do we have here? 6 volts. 6 is coming from positive to negative. That is, 6 is also coming from higher voltage to lower voltage it is coming, right? So it is coming towards the lower potential. Since it is coming towards the lower potential, you will take minus 6. And here also from higher potential to lower potential, since it is coming, whatever are on the lower potentials, they will be taken as negative only. So minus V0 divided by, what is the resistance? 6. So this is the equation for I1. In the same way, form an equation for I2. I2, how you can write? Where is I2? Here. Okay. So again, for I2 also VA obviously positive only, because current always flows from higher potential to lower potential, minus, do you have any other voltage over here? No, you have V0. V0, again, since V0 is on the lower potential, you will write minus V0 divided by, what is the resistance here? 3 ohms. Okay, V by R, right? Next, form an equation for I3 in the same way. So I3 is over here. I3 is flowing from, see here, I3 is starting at VA. So VA will be positive because current flows from higher potential to lower potential. VA is on the higher potential side. You will take VA as positive only. Next, here it is going towards VB, right? So that means VB is on what? Lower potential side. So you will take minus VB. Then what sign will you give to 5? See, forget about higher potential, lower. Of course, it is going from higher potential to lower potential only. But here what is happening? This is the negative and this is the positive sign, right? So it is going from negatives to positive, that is lower to higher. That means it will be taken as plus 5. Okay, here what is happening? Positive to negative. Okay, here also it is coming from positive to negative, right? So that is why, since here it is going from negative to positive, you will be taking it as plus 5. Okay, and next, what is the resistance associated with I3? 2 ohms divided by 2. So this is the equation that you have formed at junction A. In the same way, form an equation for currents at junction B also. Okay. So let us do it here at junction B. So at junction B, what currents are there? I4, I5, I6. So, and again, every current is going in the opposite, outwards. That is, every current is going in the same direction only, right? I4 plus I5 plus I6 is equal to 0. So this is the KCL over here. For example, here, instead of I5 coming outside, if it is going inside, then you will take I5 as minus and these two as positives, or I4 and I6 as negatives and I5 as positive. That means opposite sign you will take. But since every current is going in the same outward direction, you will be taking it as I4 plus I5 plus I6 is equal to 0. Okay. Now, how do you express I4 as? See, I4, the direction of I4 is like this, right? It is going from VB to VA. That means VB is at higher potential this time. VB minus VA. And in between, it is going from positive to negative. That means phi also will have negative sign. Okay. So what is the resistance associated here? 2 ohms divided by 2. Next, I5. So where is I5? Here. Again, I4 is here, VB is here. It is flowing from VB to V0, that is higher potential to lower potential. It means what you will write? VB minus V0 divided by, what is the voltage associated? 4 ohms. Next, I6 is equal to, I6 is here. So I6, it is VB, it is going from VB, right? That means VB is at higher potential by default. So you will be writing VB on a positive side only. Okay. Next, VB, and how it is going like this, right? So it is coming from positive to negative. Positive to negative means what? Minus, I mean higher potential to lower potential, right? So you will take it as minus 10 only. Minus, again, higher potential to lower potential, as always, you will take it as V0 divided by what is the resistance associated? 4 ohms. Okay. No confusion, guys. Very, 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 very simple. Higher potential, whenever current always flows from higher potential to lower potential. So whichever voltage is on the higher potential, you take it as positive, and whichever voltages are on the lower potential, you take them as negatives. Okay. And in the diagram, if this sign itself shows, then I3, it is coming from here, right? So coming from here, positive to negative, that is why we took plus 5. And coming to I4, it is coming from here, that is positive to negative, it is coming again, right? That is why we took minus 4. Okay, no confusion. Now let us form equations, let us solve those equations, and let us see what we will be getting for VA and VB, and then let us find out the current in this 3 ohms resistor. What is our question? Find the current in 3 ohms resistor using KCL. So what is the current associated with this 3 ohms resistor? I2. That means you have to find out I2. Okay, that means you have to find out this thing. In order to get this thing, what do you need? You need VA and V0. V0 is already equal to 0, right? So that means you need to find out the value of VA now. Okay, so according to KCL, at junction A, I1 plus I2 plus I3 is equal to 0, right? That means VA minus 6 minus V0 divided by 6 plus I2, which is VA minus V0 divided by 3 plus I3, which is VA minus VB plus 5 divided by 2 is equal to 0. When you take LCM, what do you get? You get 6 in the denominator. Here VA minus V0 minus 6 plus 3 times 2 is 6. So this times also 2 you have to do, right? So 2 VA minus 2 V0 plus 2 times 3. So this times also 3 you have to do, which means 3 VA minus 3 VB plus 15 is equal to 0. So 6 you send that side, it will become 0 anyways. So here VA, 2 VA, 3 VA, it will become what? 6 VA minus V0 minus 2 V0, you will get minus 3 V0. Anyways V0 is, anyways V0 is equal to 0. And then VB, how many you have? Just minus 3 VB. And when you add the constants, you get plus 9 is equal to 0, right? So V0 anyways it is 0. So 6 VA minus 3 VB is equal to minus 9 you can write, which is nothing but 2 VA minus VB is equal to minus 3 when you take 3 common and divide it. Okay, so this is the equation 1. Okay, now how do you get the equation 2? You get equation 2 from junction B. At junction B, I4 plus I5 plus I6 is equal to 0. So from here I4, I5, I6. Okay, let me note down those values. Okay. I just folded it so that you can see it. I4 is VB minus VA minus 5 divided by 2 plus I5 is VB minus V0 divided by 4 plus I6 is VB minus 10 minus V0 divided by 4 is equal to 0. Okay, now let's again do some math. You will get the LCM as 4. 2 VB minus 2 VA minus 10 plus VB minus V0 plus VB minus 10 minus V0 is equal to 0. Okay, so now what you will get from here, you will be getting 2 VB, 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 4 VB minus 2 VA, 2 V0 is equal to 10 when you send this 10 to that side. So now, since anyways V0 is equal to 0, you get 4VB minus 2VA is equal to 10, which is nothing but 2VB minus VA is equal to 5, and this is equation 2. Okay, this is equation 1 and this is equation 2. From 1 and 2, so these are the two equations, and if you solve these two equations, you will get VA is equal to 1.333 volts and VB is equal to 5.666 volts. Okay, you can just solve these two equations by using calculator or just directly. Okay, very simple equations, right? You just multiply this with 2 or you just multiply this with anything works. So now you got the values of VA and VB. Are you done? No. What is your task? Your task is to find out I2, right? So since your task is to find out I2, did we express I2 as, we expressed I2 as VA minus V0 divided by 3, right? So I2 is equal to VA minus V0 divided by 3, which is equal to 1.333 minus V0 is nothing but 0 divided by 3. So that means you will get I2 as 0.44 amps. So I2 is equal to how much? 0.44 amperes. So the current flowing 3 ohms resistor is equal to how much? 0.44 amperes. Okay, got it, guys? So that's all for this video. I know it's a very long video, but still I always recommend you, I should have told this in the first of the video itself, if you just follow along with me, if you do the problem along with me, then only you will understand. If you just look at the video, you will not understand anything. Okay, thanks for watching the video till the end, guys. Let's meet up soon in the next coming video with another topic. Thank you so much.